Hello everyone, this is teacher Rejil. This video addresses the competency characterize the roots of a quadratic equation using the discriminant. In the quadratic formula, x equals negative b plus and minus square root of b squared minus 4ac all over 2a. This part here, b squared minus 4ac, is called the discriminant. The table below shows the nature of the roots of the quadratic equations. If the discriminant is equal to 0, the roots are real, equal, and rational. If it is greater than 0, the roots are real, unequal, rational if it is a perfect square, and irrational if it is not a perfect square. And if it is less than 0, the roots are non-real and unequal. I understand that it is not that easy for us to memorize this table, but in order for us to understand these words, real, equal, unequal, non-real, rational, and irrational, we will include the entire quadratic formula in our computation, and we will see how this part b squared minus 4ac, which is the discriminant, plays out in our computation. Example number 1. Characterize the roots of x squared plus 6x plus 9 equals 0. This is our quadratic formula. A here is 1, B is 6, and C is 9. Plugging those values into the formula, we have this. And simplifying furthermore, we get negative 6 plus and minus square root of 0 all over 2. Why 0? It's because 6 squared is 36, and negative 4 times 1 times 9 is negative 36. 36 minus 36 is 0. So this is the value of our discriminant. From our table, if the discriminant is equal to 0, the roots are real, equal, and rational. Now, why do we say real? Real because the number inside the square root sign is not a negative number. Why do we say equal? It's because this part here, the plus and minus square root of 0, can be excluded in our computation because this is 0 anyway, and we will only have negative 6 over 2. And if we are going to solve furthermore, negative 6 divided by 2 is negative 3. So equal, there is only one root. And as a matter of fact, if we are going to solve x squared plus 6x plus 9 equals 0 by factoring, we get this. The quantity x plus 3 times the quantity x plus 3. Okay, these are the factors of x squared plus 6x plus 9. And equating both factors to 0, we have x plus 3 equals 0 and x plus 3 equals 0. Subtracting 3 from both sides, we have x equals negative 3. And for our second equation, we are also going to subtract 3 from both sides. X equals negative 3 also. So the roots are negative 3 and negative 3. They are equal, but they are the same numbers. So meaning to say, only one real root. Now, why do we say it's rational? It's rational because the square root of 0 is 0, and we don't have radical anymore. So it's rational. Example 2a. Characterize the roots of x squared minus 4x minus 5 equals 0. This is our quadratic formula. A here is 1, B is negative 4, C is negative 5. Plugging those values into our formula, we get this. And simplifying furthermore, we have 4 plus and minus square root of 36 all over 2. Why 36? It's because negative 4 squared is 16, and negative 4 times 1 times negative 5 is 20. Okay, so 16 plus 20 equals 36. So the value of the discriminant is 36, and that is greater than 0. From our table, okay, if the discriminant is greater than 0, the roots are real, unequal, and rational if it is a perfect square. Now again, why real? Because the number inside the square root sign is not a negative number. And why do we say unequal or two roots? It's because we can still make use of this plus and minus sign. So if we are going to simplify furthermore, square root of 36 is 6. So we have 4 plus and minus 6 all over 2. To find the first root, we will use the plus sign. 4 plus 6 is 10 divided by 2 is 5. For our second root, 4 minus 6, it's negative 2. Divided by 2, it's negative 1. And, okay, why do we say rational? Because it's a perfect square. 36 is a perfect square. And because it's a perfect square, we don't have radical anymore. Example 2b. Characterize the roots of x squared minus 3x minus 6 equals 0. Again, this is our quadratic formula. A here is 1, B is negative 3, C is negative 6. Plugging those values into our formula, we have this, and simplifying furthermore, we get this. 3 plus and minus square root of 33 all over 2. Why 33? Because negative 3 squared is 9, and negative 4 times 1 times negative 6 is 24. 9 plus 24 is 33. And this 33 is greater than 0. From our table, if the value of the discriminant is greater than 0, the roots are real, unequal, and irrational if it is not a perfect square. So again, why real? Because the number inside the square root sign is not negative. And why do we say unequal or two roots? Because we can still use this plus and minus sign to find the roots. Okay? As a matter of fact, to find the roots, we have 3 plus square root of 33 all over 2 as our first root, and 3 minus square root of 33 all over 2 as our second root. And why do we say irrational? It's because 33 is not a perfect square. So this 33 stays inside the radical sign. So we have radical, so it's irrational. Example 3. Characterize the roots of x squared plus 4x plus 5 equals 0. Again, this is our quadratic formula. A here is 1, B is 4, C is 5. Plugging those values into our formula, we get this. And simplifying furthermore, we have negative 4 plus and minus square root of negative 4 all over 2. Why negative 4? Because 4 squared is 16. And negative 4 times 1 times 5 is negative 20. 16 minus 20 is negative 4. Okay, so the value of the discriminant is negative 4, and that is less than 0. From our table, the roots are non-real and unequal. Why do we say non-real? Because the number inside the square root sign is a negative number. And why do we say unequal or two roots? Because we can still make use of this plus and minus sign. And we should have learned this already, that we can simplify a negative radicand. That is by factoring this number, okay, and using negative 1 as one of the factors. Because the square root of negative 1 can be represented by letter I, which means imaginary. Now, we will factor negative 4. So, we have the factors of negative 4 are 4 and negative 1. And then, of course, we know that the square root of 4 is 2. Square root of negative 1 is I. So, we have negative 4 plus and minus 2i. Okay, dividing the numerator by the denominator, we have this, negative 2 plus and minus I. To find the first root, we use the plus sign, negative 2 plus I. And the second root, negative 2 minus I. I prepared here 4 items for you to work on. Using the discriminant b squared minus 4ac, characterize the roots of the following quadratic equations. So you can pause the video and try working on these 4 items. If you are done, I can now show you the answer. Item number 1, the discriminant is equal to 36, real, unequal, and rational. Item number 2, the value of the discriminant is 5, real, unequal, and irrational. Item number 3, the value of the discriminant is 0, real, equal, and rational. Item number 4, the value of the discriminant is negative 11, non-real, and unequal. Did you get all the items right? I hope you did. Thanks for watching, guys. This is Teacher Rejil. Keep safe.